Vectors in JC is represented in three-dimensional form. That means other than x and y, we have a z. Okay, so x and y plane is no longer vertical up and this way. It is coming out of the page, along the page and vertically upright. Okay, but it doesn't matter. Actually, the orientation I want to tell you is actually it doesn't matter. But number one is when we have, if P is equals to 2, 3, 5, or I represent OP in the form of a column vector, it will be 2, 3, 5 this way. The Z just be at the bottom. And this usually question will give you in IJK form. I is the coefficient of X, J is the coefficient of Y, and K is the coefficient of Z. Just like that, representing vectors in X, Y, Z form. Okay, so now you understand this. Okay, I'm going to talk about a question that describes how we are going to do parallel vectors. So in this question, like I say, at the start, the question will always talk about position vectors. Okay, so the position vectors of A and B with respect to origin is A and B. Oh, the question is telling you OA equals to A, OB equals to B. Okay, and when anything that is in bold, you have to underline or do it curly. Okay, show that the point P with the position vector of this is collinear. So the question also tells you that OP is equals to lambda A plus 1 minus lambda B. So you realize that there's lesser numbers, more alphabets, okay, in JC. It's collinear. So the question asks you to show. Can you say that they're on the same straight line now? No, you can't say that they're on the same straight line now. Okay, so this is P, yeah. Okay, but P might be in the middle because they never say produce, okay? Not say in the middle, in between, yeah. Okay, and then B is here. So I know that if I want to show, it means I have to show that AP, I'm just going to use AP, yeah. AP is equals to, you know the basics is called like K times of, yeah, AB. Okay, in this case I use is a K. Now, what is the K? A K is a constant. It's the constant that I have to determine. Okay, so I have these three. First, I find out what is AB. Now remember AB, the behind guy minus the front guy is just B minus A. Okay, so that's AB. Next, I find out what is AP. Okay, AP is P minus A. But I want everything in terms of B and A. So I'm going to put the P from here into here. Okay, lambda A plus 1 minus lambda B, then minus A. Group all the A's together. Lambda A minus A plus 1 minus lambda B. Okay, now I have A as a constant, so I factorize the A out. I will have lambda minus 1 plus 1 minus lambda B. You realize that the proof is coming out already. Flip this to become 1 minus lambda. Negative A, 1 minus lambda plus 1 minus lambda B. Oh, factorization by grouping. Take out 1 minus lambda. You are going to left with minus A plus B inside. What is minus A plus B? Minus A plus B is the same as B minus A, which is just, okay, I should underline all my A's and B's, which is 1 minus lambda kind of AB. What have you shown? I have shown that AP is equals to 1 minus lambda times of B. So since AP is equals to K times, you can say, okay, K times of AB, and they start at a common point A, B, P, B are collinear. Okay? So in this case, same thing. AP is equals to 1 minus lambda kind of AB. A is here, P is here. I don't know whether P is shorter or P is longer. I don't know, and it really doesn't matter. Okay? So AP is 1 minus lambda kind. So take AB as 1. Here is 1 minus lambda. That's what it means. Okay? And what would PB be? This one you must immediately know. Okay, so this guy is called lambda. Okay, and so this is a type of question that we use the same concept as what we learned in secondary school, but it's just that we are going to apply it in a more advanced way because we are doing H2. So going back to this, now that we learned that a vector in 3 dimensions is x, y, z, okay, and we put in IJK form, it is the coefficient of x, coefficient of y, and coefficient of z. Okay, there are two things that we are going to learn today is, okay, finding a unit vector. Now, before we find a unit vector, the magnitude, which is the length of a vector, is still the Pythagoras theorem of x squared plus y squared plus z squared. Okay, any two vectors you can add or minus. When you add means x plus xy plus yz plus z, and you can multiply by a constant on the outside, means all of them is going to get a constant. So next part is called a unit vector. A unit vector is a vector with magnitude 1, and this concept is important, okay, because we will need to use a unit vector in some forms later on. Okay, so when we will see a unit vector it is called a hat. This is when we call it a hat. Okay, and the formula for this is the vector divided by the magnitude. A vector divided by the magnitude of A. Okay, why is this so? So for example, let's say you have this B guy, and I tell you that he is maybe 122. Okay, and with 122, I know that the magnitude of B is equals to square root of 1 square plus 2 square plus 2 square, which is 3. So the length of B is 3, which means that I can split this into 3 parts. 1 unit, 1 unit, 1 unit, because the length is 3 units. Yeah. So if I just want to take 1 unit over here, can see this 1 unit over here. This guy is called B hat. And what is B hat? This guy is called 1/3 of B, which gives you B divided by the magnitude of B. Okay, this guy here is also another B hat. This guy here is also another B hat. Okay, but this is very technical, so don't worry about the technicality of this. Just know that a unit vector is represented by A hat or B hat or C hat or anything hat, and a unit vector has a magnitude of 1, okay, and it's in the same direction. And the technique of finding a unit vector is A over magnitude of A, and after we do this, usually we represent it as a fraction on the outside, 1 over square root 14, where square root 14 is the magnitude of A. Okay, don't understand this? Just look at this again. Now the length of B is 3. I just want one portion of 3, but B is a vector called 122. So B hat is called 1/3 of 122, just like that, because I want to divide it into 3 pieces. And why 3 pieces? Because the magnitude of B is 3, just like that. Okay, so next is called vector displacement. Is that any form of vector that is in the same side and the same length and direction can be moved from one place to another. That means this is the normal triangle, right or not? Okay, so in a parallelogram you see this. You must know that V over here and V over here is exactly the same. So I can move it from here to here. Okay, so if I want to prove that this is a parallelogram, all I need to prove is that, for example, I use A, B, C, and D. AB is equals to DC. A pair of parallel lines exactly the same, can already. Or you can prove the opposite. AD, okay, is equals to BC. Be careful, the direction is so important. Okay, and then the next part is in a polygon. So same thing. I don't have to understand this very complicated one. Okay, I'm just going to use a very simple example like a hexagon. Okay, to show you how vectors can be displaced. So if you look at a question like this, okay, it says that it is a ABCDEF is a regular hexagon. So a hexagon has 6 sides, 1, 2, 3, 4, 5, and 6. And what you must understand is that all the sides in the hexagon are equal. And not just that, and because when I divide by 6, right, divide by 6 triangles, right, each angle is 60 degrees, right, it makes everything inside, everybody, okay, to be exactly the same. We just ignore the question. If I just going to label this as A, B, C, D, E. A, B, C, D, E, F. Okay? And I say that, AB is called A. And BC is called B. Okay? So what I want to tell you is that anything that is straight going on here, okay, because they are all of the same length, it is the same. So AB essentially you can say that is equals to ED because it is in the same direction, the magnitude is the same as well. Okay, and if you look at FC, FC is over here, right? What can you say about FC? FC would be 2A. So all these are A, FC is 2 times of A because the length is 2 times of the AB. Why? Again, hexagon is all an equilateral triangle, all the sides are the same. Okay, so now I look at it in terms of B, I'm going to use green for B. So if B is here, this means that, okay, I label the middle as O. AO is the same B as well. And actually, this is not a very good way of drawing this. If you don't draw it nicely, right, then you will not realize that actually AD, right, AD this way, right, yeah, AD is the 2 times of B. Okay, as well as FE this way is also equals to B. Okay, so this is how what we say that vectors can be displaced. You can move it around. Okay, you can move it around, and exactly when the vectors have the same length and the same direction, you can say that they are exactly the same. And if the length is doubled, then it's just 2A. If the length is tripled, then it's just 3A. If the length is half, it's just half A, just like that.